Assalamualaikum and greetings. Today we want to present our integrated design project, which is the reusable coolant filtration system. Before I start, we are from Group 8. My name is Wan HAIKAL bin AZHAR. We are under the supervision of Professor Madya Dr. Liu Pei Zhen. Nowadays, we are living in a world which is producing more and more waste every day. The increasing environmental pollution requires new ways of waste management and innovation to stop the ongoing contamination of our planet. Hence, we believe that our product will slow down this trend and help reduce environmental pollution. Therefore, we have taken the initiative to design and fabricate a reusable coolant filtration system. By analyzing the current situation, we found that factories and workshops tend to dispose used coolant filter, which will create landfill and pollution. In addition, the current coolant filter for machining process are non-reusable. Last but not least, the durability and lifespan of existing coolant filter are low. Due to this, the filter need to be thrown out after use. With our product, we implement our vision of producing sustainable product which will help eliminate environmental issues. With this finding, we form our objective of designing and fabricating a reusable coolant filtration system. Furthermore, we want to reduce waste disposal of coolant filter in our effort to help maintain the planet. Lastly, we want to improve the lifespan and durability of the coolant filter.
Assalamualaikum, my name is Farez Amsyar Zulkifli, and today I will talk about product description and analysis. First, I will talk about the filtration system parts. There are 7 parts, which are filter, valve, bracket, magnet, drain plug, cap filter, and body filter. First, we will talk about the simulation of our filtration system. The first image on the left talks about the mechanism on how our product works. And on the right top is the disassembly mechanism of our product, and the bottom of it is and how the magnet will work in our product. You can see that the coolant went out of this filter. Then I will talk about valve analysis. The analysis is done via analysis of valve. This is the simulation of how the coolant will travel in our system. The mass flow rate of the system is 0.01 kg per second, which we calculate manually using formula. When the velocity is high, the pressure is low, and vice versa. As you can see, these two images shows the velocity and pressure. The maximum velocity is 6.7379 to the power of -1, and the minimum is 0, while the maximum pressure is -1.150 to the power of 2, and the minimum is -2.397 to the power of 2. Now the bracket analysis. First is the total deformation of our product. The maximum deformation is 0.016411 mm and minimum is 0. You can see the graphical image on the left. Second one is equivalent stress. The maximum is 10.636 megapascal, while the minimum is 2.1213 to the power of 13 megapascal. For safety factor, the maximum and minimum is 15, which shows that our product is good and the spring can contain the weight by the system. And lastly, the equivalent elastic strain. The maximum equivalent elastic strain is 5.5108 to the power of -5, and minimum is 1.0992 to the power of -18. That's all for the analysis. Thank you.
This is the working example for our prototype. The fluid coolant will enter through the inlet hose and fill the body. After the body is full, it will flow through the outlet.
Assalamualaikum, my name is SAZLINA binti SAMAN. This is the flow of manufacturing process. From choosing the material, and then we can proceed to the shaping process, joining process, and the final step is finishing process. Shaping process that we choose is plastic injection molding, bending machine, lead and milling machine, and the last one is laser cutter machine. For joining process is MIG welding. For finishing process, we choose spray finishing. As we can see, this is our final design for the reusable coolant filtration system. First, plastic injection molding is a process for producing parts by injecting molten material into a mold. We use this to make the body housing and cap that are made from polycarbonate. Next, we choose laser cutter machine to cut the stainless steel plate for the bracket. So, we can proceed to the next process. Bending machine is a process that we use to bend the stainless steel plate into U-shape. Lathe machine is a process that have various operations such as cutting, nailing, drilling, and facings. This process is suited for making the valve. Next, for joining process. MIG welding is used to join the bracket parts for holding the body material. The last step is finishing process. Spray finishing is used to spray the bracket to increase the endurance and to make it more bright shine.
My name is NORETASYA IRUANI BINTI HASHIM. Okay, for the sustainability, we have material selection table. In terms of material, we use design requirement. First, for body housing, the material we choose is polycarbonate. This is because polycarbonate material weighs about half as much as its class equivalent, which means easy to move and storage and simplified material handling. For function, is to store the coolant and filter. For the constraint, is height, friction tightness, and height density. For the objective, is to minimize number of components. For free variable, is choice material. Next, this is material properties chart for the body housing. We are developed these charts by using chest EduPad software. We use factory tightness against the city for this chart. Second, the design requirement for filter movement mesh. The material we selected is stainless steel. This is because stainless steel can be used in design to reduce material thickness and reduce weight and cost. For the function, is to filter the metal and chip from machining process. For the constraint, is great strength and good corrosion resistant. For the objective is to minimize the effectiveness of filter system. Next, this is material properties chart for filter movement mesh. We use tensile strength against elongation for this chart. This is also developed by chest EduPad software. This is table for material selection that we selected for the polycarbonate and stainless steel. For the sustainability analysis, we are consider the design for environment DFE for our product reusable coolant filtration system. The FE consists from environment, society, and economy. Next, life cycle analysis is consists three things such as recycle, material, and manufacturing. Lastly, this is example of the FE, the Eco Web design. For the filter is using stainless steel material, and for the body housing is using polycarbonate material. In the case of each template, it has been shown that all criteria have a good impact on each component. That's all from me. Thank you.
Assalamualaikum and salam sejahtera. My name is MOHAMAD IZHARUDDIN bin AHMAD, and I would like to present about cost analysis, which consists of fixed cost, variable cost, and break-even point. This is the material that we use, which is stainless steel, polycarbonate, neodymium, and brass. What is fixed cost? Fixed cost with costs that not changed and being paid by a company, such as rental cost and labor cost. In producing this reusable coolant filtration, we assume to hire 10 workers, so the company need to pay monthly payment Rm2,000 per person, electric bill Rm1,300 per month, water bill Rm300 per month, and the maintenance cost is Rm1,000 per 10 machine. So the total of the fixed cost is Rm27,600 ringgit. Then for the variable cost, which it consists that are changed due to quantity that need to produce the product. Here are the list of the materials that been used to produce the reusable coolant filtration system. The total cost of the raw material is Rm103 ringgit. Then the selling price for our product is Rm289 ringgit, include production fee. Next, break-even point is a point where the total cost is equal to the total sales, and the break-even point can be calculated by using the formula that been shown. Besides, break-even point can be known by constructing a graph where the two lines be intersect. The company will achieve the profit when 149 units are being sold. This is the buying method which consists of body housing, filter woven mesh and magnet. Thank you.
I will continue with the conclusion. Lastly, we can conclude from this project is that our objective of designing and fabricating a reusable coolant filter has been achieved. Next, our product also helped improve the lifespan and durability of the coolant filter. We are certain that our product will greatly benefit machining factory and industrial workers by ensuring coolant are being filtered decently in order to improve surface quality of machining workpiece. The concept would play an important role in terms of product efficiency, reliability, and respect for environment. The product is designed in such a way that the material chosen and the manufacturing process chose bring environmental improvement and a sustainable development strategy. That is all from us. Thank you.